So this is about Ampere's law. What is this? Ampere's law states. This is also this statement is also about the magnetic field which is developed due to the current passing. In Biot-Savart's law, we have chosen a long conductor, but in Ampere's law, we choose a circular loop. It means a long wire whose two ends are connected, joined. Then we will have a circular loop like this. Here. And we pass the current through this loop. So this is the current flowing through the circular loop. I amperes of the current is flowing through this one here. So we can pass this current in other direction also. For meanwhile, I take in clockwise direction. So we consider that I amperes of the current is flowing through this circular loop in clockwise direction. And the radius of this circle. So this is the center of the circle here. And radius of the circle. This is radius of the circle. R is the radius of the circle. So we denote with R. So a circular loop with radius R and current flowing through this circular loop, I amperes. Then magnetic field is developed at the center of the circular loop. Here Ampere's law statement is about the magnetic field at the center of the circular loop. And Biot-Savart's law, it is due to the long conductor. This is the difference here. So in this Ampere's law, the magnetic field at the center of the loop, so we denote with B. B is the magnetic field. It depends upon two factors. So number one, current flowing through the conductor, I mean circular loop. The second one is here, so it depends upon radius of the circular loop. So these two are the factors on which the magnetic field at the center of the circular loop depends. How? So according to Ampere's law, this magnetic field B, it is directly proportional. So directly proportional here. So this is directly proportional to current. Current flowing through the conductor. So this is the current flowing through the conductor. So this is the first factor on which the magnetic field depends. The second one again also directly proportional to radius. But this is highlighted as 1 by R. It means inversely proportional to radius. As the size of the circular loop increases, then center is away from the perimeter. That is the current here. So current flows through the perimeter. No, so this is the perimeter of the circle, circumference. What we call this is a circumference of the circle. If the size is very large, so if you take a large loop here like this is the large loop, then center will be away from this circumference and the current also. So the magnetic field which is developed at the center decreases as the radius of the loop increases here. For smaller loops, we have the maximum magnetic field. For larger loops, the field is decreased here. So this is magnetic field which depends upon the current and the radius. Now we combined these two. When you combine these two, the magnetic field directly proportional to, so this is the directly proportional here, directly proportional to current. So this is the current here, so I, and inversely proportional to R. So I'll write 1 by R here. So if you write like this, then it will be proportionality symbol is replaced by a constant. So we will replace this proportionality symbol with a constant and multiplied by here I by R. So this proportionality constant, as we know, it is the magnetic field. So this is the magnetic field, which is equal to here. We denote this proportionality symbol with mu naught. This is the proportionality symbol divided by, we take 2 pi. Remember, in Biot-Savart's law, this proportionality symbol is mu naught by 4 pi. But in the statement of Ampere's law, this constant is equal to mu naught by 2 pi and multiplied by I by R. So this is I by R. So we can write this as here B magnetic field equals to mu naught I. So we can write it as mu naught I in the numerator divided by 2 pi R. So 2 pi R. So this 2 pi R is the circumference of the circular loop. This is the magnetic field due to the circular loop. But remember, this magnetic field is developed at the center of the circular loop. So this one 2 pi R circumference. We divide this circumference into small elements here. So if I divide this circumference into small elements and whose length equals to dl again here. So length of this small element, this is dl and integral dl equals to total circumference. So this 2 pi R value is written in terms of integral of dl. So this value P equals to mu naught I. Mu naught I value here by this 2 pi R value is replaced by line integral dl. So I will take this line integral dl to other side. Then this will be B line integral dl equals to mu naught I. So we can rewrite this as line integral. We will take this B inside the integral B dot dl equals to mu naught I. So this is written in terms of integration. That's why this is the integral form of Biot-Savart's law. So this is integral form of Ampere's law. Integral B dot dl equals to mu naught I. Here B is a vector. B is a vector, so this vector we will put an arrow mark here, and dl is also a vector. Because this space region around this circular loop is a vector, since a vector is calculated, a vector is flowing. When a vector is flowing in a space, that space or field is called vector field. So the length of the or circumference of the circle is a vector, integral B dot dl. So which is equals to mu naught I. This is the integral form of Ampere's law. This one.